Chapter on calibration of laser. Next, I will teach you how to calibrate the laser and the SY deviation value of the probe and the height. Now we open the jet head to a distance of 5 mm from the surface of the plate. This height of 5 mm, we can use a 5 mm hex key to assist. Just enough to pass. Now control the distance at 5 mm. After that, we perform a z-axis zeroing here. Originally SY zeroing. Then, now we turn on the oil pump. Open the water valve. Open the high pressure valve. Create a hole with it. Create a hole. After piercing, we close the high pressure valve. After it releases the pressure, we close the water valve. Finally, we turn off the oil pump. Now, after we raise the jet head, raise it to a safe height. We go to the hardware part here. Scroll down. Find this Y09 height measurement. Click to open the test. Let it bounce down. If you are prompted for a password during this process, if it prompts for a password, it is the name of the software. Now, we click on Measure Height to activate the projection of light. It will have a dot. Now click on Manual. Move the cursor to the spot where we made the hole earlier using the water jet. It must be accurate. It must be in the center. If it doesn't work, we can go to this side. Move it with a speed multiplier of 0.1. After moving to the center, we need to click on Manufacture here. Then remember the coordinates of this workpiece. It's the workpiece coordinates. Input it into the SY deviation value here. Now confirm. Now raise the height gauge for testing and close it afterwards. Cancel all. This is a necessary step. Then click on Continuous in the Trajectory section. In the Operation section, if there is a probe, click on this step. Profile Detection. Then lift it up slightly to pop out the probe. It should pop out at a safe height. Similarly, click on Manual here. Click on Manual. Move the probe head of the probe to the center position of the hole. It must be in the center. If it's not in the center, there will be a deviation in the final result of the basin. Regarding the probe, if you feel it's getting close to the plate or edge, use a manual speed of 0.1 to move it slowly. Now, after aligning it to the center, return to this side. Similarly, click on Manufacturer. After entering the password, input the SY deviation here. Input the data here. Click on Exit. Now the probe and SY deviation for height measurement are already set. Next, we are going to set the height. In terms of height, let's start with the probe's height. Click on Profile Detection. First, retract the cutting tool. Move the cutting tool to the desired probing height. Move it here. Because we have already zeroed the z-axis earlier. So now we don't need to perform this step again. If the z-axis was not zeroed earlier, we now need to lower the cutting tool to 5 mm. Afterward, we zero the z-axis. Then we perform this step again. Now, click on Manufacturer. Obtain the cutting height difference. Click on Get Cutting Height Difference. Now it will automatically obtain this height difference. It will precisely touch the surface, and then the signal will be transmitted. In the next step, he will sense it. Now there is data available in this area. The height difference has been set. Now exit. Next, we need to set the height difference for height measurement. The height difference for height measurement is the same. Move the cutting tool slightly in this direction. For height measurement, it's best to dry the water on the surface first. Now let's zero the SY. Then click on Height Measurement. Click on the Manufacturer button. There will be an option for Automatic Height Difference Detection. Click on it. It will automatically perform the detection. Now, after the detection is complete, a numerical value will appear here. Now the height difference detection is completed. I want to check the accuracy of this height difference. What should we do? At this point, we need to draw two lines. First from left to right, and then from right to left, cutting at a 45-degree angle. Let's draw two lines with an angle of around 30 degrees. Leave a gap of about 3 mm in between. Now let's set an origin here. Save. In the Options menu, choose the XF options and make sure the Object option is selected. Then confirm. Then save again. Click on Origin and then select these two lines. Press the spacebar. Go to this side. Open the previously saved file. After opening, delete the tool compensation. The left and right inclinations of these two lines are different. Although they are both cut at 47 degrees, their lines are different. If one line is inclined to the left, the other side must be inclined to the right. These two lines must be opposite. Now save. Now, at any position on the surface, set SY to 0. Then click on Height Measurement. Perform Scan Height. Confirm. Let it perform the height measurement. After measuring the height, proceed with cutting. After cutting, let's evaluate the result. The effect looks good. Now we have finished cutting. Let's look at these two lines. It is evident that this line is slightly lower than the other. At this point, we need to go back to the height measurement section. Check the manufacturer option. Adjust the data. As the right side is slightly higher than the left, we need to increase the data. If after increasing, it becomes opposite, we should decrease it. Initially, it was 39.3. Now let's try changing it to 39.5. Usually, it's a 0.2 increment. After making the adjustment, let's cut again. We can see that the difference between these two lines has increased compared to before. So, the data should be decreased. Previously it was 39.3, and now it should be changed to 39.1. After changing it to 39.1, let's try again. Our ultimate goal is to have these two lines perfectly aligned as one straight line, without any height difference. This line is the one we just cut, and achieving this effect is sufficient.